Yeah, I'm going for that.
Actually, I'm really going for
Attendance! I know, I'm gonna get it. Okay, so today we don't really have much to do. We're going to do a lab, and then before that we're going to go over a review quiz that you guys took, which you guys did not do very well on.
What was the average?
The average was about 64%.
That wasn't bad.
That was for G4. The average for you guys was 6%. Oh wait, actually it was better. It was 7%, because one person got 100%.
Michael.
Okay, so here's the elevator problem, which is the same question that was on your last 7 tests, but you guys still only have a 20% mastery level. A woman standing on a scale descends in an elevator that briefly accelerates at 1/2 of the acceleration of gravity downwards. During this acceleration, what does the scale read in comparison to her actual weight?
Well, I thought that the scale would read more than the woman's actual weight because I thought that the downward acceleration of the elevator would be added to the acceleration of gravity, making the woman heavier on the scale than she actually is.
You first have to understand that the scale's reading is based on the normal force of the scale. Since F net equals all the forces applied equals mg minus Fn equals ma, the Fn would equal mg minus ma, whereas her actual weight is only mg. Since mg minus ma is less than mg in all cases, the reading of the scale is less than her actual weight.
Oh!
So, what was so difficult about that question?
Well, I just forgot that it was supposed to be normal force on the scale.
I drew the free body diagram, but I didn't know what to do from there.
So, you guys know the physics concepts, but you just don't have common sense? Only 20% of you got this right. If I were to give this problem to my daughter's 4th grade friends, 25% of them would get this right. That means I made you guys worse at physics. Okay, alright then. Moving on to the second question. The problem asks why a child in a wagon seems to fall backwards when the wagon is pulled forward sharply. Many of you guys got this wrong, and this tells me that none of you guys have been doing your homework, because there was a problem exactly like this on your homework. So, I'll explain it to you. According to Newton's first law, an object in motion stays in motion until a force acts on it. In this case, the child remains at rest until a force acts on her. The force acts on the wagon, not the child, so the wagon accelerates out from under the child, making it look like the child falls backward relative to the wagon.
Bueller. He's sick.
Haha, I already got the attendance. Okay, so moving on to the next question. The problem says that a tire swing hanging from a branch reaches the ground. What values would you need in order to estimate the height of the branch using only a stopwatch?
I had no idea what to do with that question, so I just guessed randomly.
Well, you need gravity and the mass of the tire, right?
Yes, you do need gravity, but mass is only applicable to calculating the period of a spring. The tire swing is essentially a pendulum because it consists of a mass at the end of a non-stretching cord. For pendulums, to figure out the height of the branch, you would only need the acceleration of gravity and the period of the pendulum to figure out the length. Okay, so for the next question, you guys did not do too bad. But 3 people put E as their answer choices. 3 people! The choices are A to D.
Was one of them me?
No, I don't think so.
Oh, well, was one of them Duncan?
Actually, no.
Oh, I think I put E. You can tell me in front of the whole class. I mean, I don't care.
Well, I'll have to look it up on this app on my phone, and it'll take too much time. Okay, let's just move on to the next question. Okay, so the problem states that you lift a suitcase from the floor to the table and asks whether the work you do depends on the path taken. That's for part A.
I said that it does not depend on this because lifting up a suitcase does not include any non-conservative forces, whether it's a straight path or it's complicated.
Good, because a non-conservative force depends on the path taken, and this example doesn't include any. Okay, so for the next part, does the time it take have an effect on the work?
No, because time isn't a part of the equation. Work equals FD cos theta.
Good. Does work depend on the height of the table?
Work does depend on the height of the table because the force applied is going upwards, therefore the displacement would be the vertical displacement.
Yes, you're right. For the next part, does the weight affect the amount of work done on the suitcase?
Because the weight of the suitcase creates a downward force because of gravity, mass times gravity, the applied force necessary to move the object the opposite direction upwards needs to first counter the weight. So if it's a larger weight, you need a larger force to counter it. Since work equals FD cosine theta, the greater force, the more work done.
Good job. Oh wait, it looks like my daughter is calling me. Hello? Are you on the bus right now? What do you need? I'm in the middle of class right now. Okay, bye. Okay, we're going to start a lab today to study harmonic waves. It's pretty self-explanatory though, although one of the groups in the other class took a whole hour to do it.
Hey, Stephanie. Oh, the lab?
Yep.
Oh, okay. I think we're supposed to use the equation F equals NV over 4L to find the theoretical lengths of the tube for each harmonic, since the tube is open-closed, so the coefficient on the bottom will be 4. Since we do have the recorded frequency, which is 440 hertz, and then we also have the N values, and we also calculate the speed of the sound, all we have to do is plug those values into the equation to find the lengths.
We have 30 minutes left. Fellers, I'm going to go to the bathroom. It might take about 30 minutes.
Okay, have fun at your counseling meeting.
We got a 180% error. Is that okay?
Hold on 1 second. Hey, Michael, what percent error did you get?
250.
Okay, we're okay.